Good evening, one and all. Welcome back to QCrete webinar series number 53. I am Anjali Payas, working as the technical coordinator with QCrete Readymix India Private Limited, and it's my honor to welcome the office bearers of ICI Kochi Center. First of all, I welcome Dr. Anil Joseph, the chairman of ICI Center Kochi. A hearty welcome to you, sir. Next, I welcome Dr. Elton John, the Vice Chairman. We welcome you, sir.
Thank you, Anjali.
Thank you, sir. Next, let me welcome Dr. Sunita Nair, the Joint Secretary. We welcome you, madam. Now, next is Dr. Job Thomas, the Secretary of ICI Kochi Center. A hearty welcome to you, sir. Next is the Treasurer of Cochin ICI Center, Engineer Shaiju Nair. We welcome you, sir. Once again, on behalf of QCrete Readymix India Private Limited, I welcome all the office bearers of ICI Kochi Center to this webinar session. Next, I would like to welcome the Managing Director of our company, Engineer Shelly S. Fernandez. Finally, I would like to welcome Engineer V.R. Kaushika, Director of QCrete Readymix India Private Limited. Now, handing over to Dr. Elton John for the welcome speech. You may continue, sir.
A warm good evening to all. So, respected Anil sir, Chairman ICI Kochi Center, Engineer Shelly Fernandez, Founding Chairman of ICI Kochi member, Honorable Speaker of the Day, Anil Anjanappa, and all the office bearers and management committee members from QCrete Readymix Concrete, Kaushika sir, and all are present here, and dear participants. Today we are fortunate enough to have a very special person with us, Anil Anjanappa, to talk about a very, very important but not much popular area in concrete technology, the applications of fibers in concrete. So we are talking about the cracks, issues, and everything in concrete, but the technology to arrest it. The major problems concrete is, one is crack and the other one is the brittle nature of concrete. We have various fibers available in the market which can tackle these issues. So the cracks starting from the initial stage of concrete, maybe after 1 or 2 hours of casting, we are seeing the cracks, and it can go for a long time. After 20 or 30 or 40 years, the cracks can start. So we have different solutions for that. And what is the fibers in concrete? So we have the different types of fibers like polypropylene fibers, steel fibers, carbon fibers, glass fibers, nylon fibers, natural fibers like sisal, coir, and all these things. So today we have an eminent and expert in the area of fiber reinforced concrete, Anil sir, with us. He is the Executive Director of Tremco CPG India Private Limited. So as the time is lapsing, we have to listen to him. So I'm not wasting much of the time. I would like to welcome all the dignitaries present over here, especially the Speaker of the Day, Anil Anjanappa, to the program. So all these others are present here. Already Anjali has mentioned this. So in a single word, I welcome all the dignitaries to this program, and all these programs will be success only the support of the participants. We have already more than 200 participants attending this program now, so the number will go on increasing. So that's again, I invite all the participants for these programs. And before winding up, I would like to express my gratitude to QCrete Readymix for giving an opportunity to join hands with ICI and QCrete and coming up with this innovative and new areas in concrete technology for the betterment of the quality of concrete construction in India. So once again, I thank QCrete and especially the Managing Director, Shelly Fernandez sir, for this opportunity. Thank you all.
Thank you, sir. I think really appreciate your wonderful introduction, and I would like to thank the QCrete team and the ICI Cochin chapter for giving us this an opportunity. On behalf of Trimco CPG management and the entire team, I would like to thank each one of you, and I would like to welcome all the participants who have joined until now and the future. A warm welcome, and I know it's a Friday evening, weekend starting, and I'll try to keep it as interesting as possible. And as I'll see that your weekend does not go bad. Okay, so I just want to tell what sir said is that I'll be talking about not only on cracks, I'll be also talking about microfibers, which will be more from replacing of steel, which probably is one of the hot topics in today's market, in today's construction industry. So this is something which is our topic, FRC and its new opportunities in today's market and construction scenario. So this is what I would take you the entire presentation through. So what I would do is I would just with the permission of the ICI and yeah.
Anil sir, just as I think there will be introduction about you by Indu Susan Raj. Just
okay, sorry.
Yeah, no problem.
Sorry.
Before that one, I just want to tell that QCrete is conducting these webinars since the COVID times, and this is the 53rd webinar, and we are really thankful to Mr. Anil Anjanappa for accepting our invitation. And you can see all these webinars on our website, www.qcreteindia.com. Thank you.
Thank you, sir. Myself is Indu Susan Raj. And good evening, everyone. Today, this task of introducing our guest of honor and speaker is a great privilege for me. I feel delighted to introduce Mr. Anil. Pardon?
You may continue.
Okay. I feel delighted to introduce Mr. Anil Anjanappa to everyone tonight. Our speaker is the Executive Director of Trivandrum CPG India Private Limited. And Mr. Anil Anjanappa pursued his graduation in Civil Engineering from Bengaluru University, MPF from Indo-German Training Center, Mumbai. And coming to his experiences, he has 28 years of total experience in construction and construction chemicals field. And during this period, he involved in introducing PCE, SCC, high performance, PU concrete flooring, PVC membranes, and PU sprayed membranes in India, etc. And some of the key projects added to his credit include Bangalore International Airport, nuclear power plant at Mangaluru, and Bengal Tunnel, and many more prestigious projects across India, and the list is endless. And looking forward to his current roles and responsibilities, and first of all, is to build the brand of Trivandrum CPG in India as a single point solution provider for all the construction chemical needs of the construction industry within the shortest possible time. In addition to that, to make it as preferred brand for employees and customers in South Asia, to work by recruiting the right talent from the industry, train them, and introduce new product systems from our global portfolio to solve customer problems at a design and execution stage. This is a brief introduction about our speaker. Enjoy the webinar and enlighten your knowledge. Thank you.
Thank you, madam. Thank you for the wonderful introduction. And sorry, I just started before you did it. I'm really sorry for that. Okay, can I move on?
Yes, sir. Yes, sir.
Okay, thanks. So what I was just talking to, other than what doctor said, is I'll be focusing on different types of fibers, what is coming up and where we can all take an advantage of that. So what I will do is what is FRC, a basic introduction to everybody, then types of fibers in the market and its performance and how do you design it when it comes to slab on grade, composite deck, jointless floors, and many other opportunities like how to avoid cracks and other this one. Okay, mainly this would be my thing, and I'll also share some case studies to all of you to just to see that it's not just speaking about it, it's also about how things have been made it into reality. So just an introduction with the permission of ICI and QCrete, I've just taken this so that at least people know from where we are speaking about it, and it's not that none of us know this company. So we all belong to a company called as RPM. It is called as Republic Powdered Metals. It's a 6.71 billion organization based in Cleveland in US. That's around 53.6 thousand crores company globally. And it's listed in New York Stock Exchange. We've acquired around 175 to 180 companies in last 35 years when it comes to technology. So under RPM, as I said, we have got 4 groups. So the group which we belong to is construction product groups. You can look at the technologies, what we have. One of the leading brands in the global is under our umbrella, whether it is admixtures, whether it is waterproofing, whether it is fiber, whether it is fire protection, whether it is color concrete, you name it, probably will be one of the companies which has everything under umbrella. And in the near to future to come, I think you will see the technology is getting released in India also. So in India, what is the advantages all of us can take is under the brand of Tremco. Vandex is there, then the entire waterproofing range. Then glazing is one of the products which we work on, especially the sealants, tapes, and EPDM rubbers. Flooring, all of you know that the brand is QCrete, and you name the flooring solution you want, from fibers, densification, polish, epoxy, terrazzo. Will be available. Euclid is an 110-year-old brand globally, and for anything to do with fibers, admixtures, repair mortars, we would be able to serve through this particular brand. Wilseal is another organization which will be getting into India, maybe in next around a year or two, which is into preform joints of flooring and the multi-level car parking and buildings there. Another one which probably none of the construction chemical company has here is the nullifier, the fire protection system for composite steel deck, which is basically into cellulose fires. And Drive-It is something is for the one which is coming up in the next few years time, which India is going to catch up, is externally on external insulation and facade system. This is a small brief introduction of the organization. So coming to the main topic, what we are talking about is only on the fibers. Okay, so fibers, this is not something new to us. Okay, probably we are using this as a fiber in today's world, but all of us know when you look at 500, 400, 300 years, when people used to go to their village, when they used to see the straws getting mixed in, whether it is on the mud or even mixed with the cow dung, that was mainly used to give the post-crack strength to each of this particular part. So this is not something new today, but it also was used in a very primitive age, and that is something gone to the next level of technologies with design and other things for the execution. So majorly what we would be speaking today is on the structural macro fibers, which will give you additional tensile and flexural strength other than crack reduction part of it to the concrete. And by doing this, basically what happens to the concrete is the integrity and durability of the concrete gets increased because there is less cracking happening. As all of you know, with one small crack in the concrete, the entire deterioration or corrosion or whatever happens in the concrete starts with that. So the basic thing is to see, as a civil engineers, all of us, to see that can we give, I know that it's really impossible to give without a small crack, but at least we can reduce it to 95 to 98%. Probably that itself is going to be a big achievement to us as civil engineering fraternity. So there are three types of fibers which we would focus today, other than what Dr. said. Basically, microfibers is what a lot of people have used. People who are attending the seminars and who are also not attending, these are a small fibers with between 8 to 10 mm or maximum 12 mm, which is only used for reducing your plastic shrinkage crack. It does not give any physical properties increase for the particular concrete. So please understand, a lot of people come to us and say, yes, I'm using fiber and it should be done. No, it cannot be done like this. And the properties of microfibers is only to reduce your plastic shrinkage crack, nothing else other than that. The macrosynthetic fibers is what majorly we'll speak today, is something on not only on shrinkage control you are doing it, and also you can do limited engineering replacement of steel reinforcement for the non-structural elements can be done. So that's why we talk about dosages from 1.8 to 12 kg per cubic meter. So this is a designed, structural designed element, what we are talking about through macrosynthetic fibers. So the focus will be on that. Steel fibers, I think quite a lot of people know about it. It's also a great product to have. But yes, all the three R's comes with their own advantages and disadvantages. Looking at the risk analysis, we should choose the right one for right application, and the execution should be flawless. Only then you get the right product. As I said, just because we are from a US organization, I just want to tell you very clearly, in the US market, the use of fibers is far ahead as compared to any part of the world. They use fibers literally because of the freezing and thawing what happens in US to the extreme temperatures. So from that particular thing, the fiber market in US is very big. Okay. So when it comes to there, you can see the types of fibers we have. Even in microfibers, we have based in nylon, we have monofilament, fibrillated. Then there is a blend of macrofibers with microfibers. So they do the designing of concrete with lot of blends of fibers also for achieving different properties in concrete. So this is again an engineering part. It is not that you take a packet of fiber, you add it and you get the output. Here you have to test it, design it, test it, and then you need to execute it at the site level. So this is what it is all about. To just introduce, say that it can be 10 mm, it can be 20 mm, it can be 38 mm, it can be 45 mm, it can be 51 mm. So these are the different sizes of fibers are available in the today's market. So what is macrofibers? This is one of the topics which we'll be focusing heavily. It not only reduces your plastic shrinkage cracks. The most important thing is, as I said, for a conventional steel, if you design it properly, we'll be able to reduce the rebar and the wire reinforcement coming up in the non-structural elements is what the use of macrofiber is. So please understand again and again, I'm reiterating again, there is a difference between microfiber and macrofiber. In microfibers, we will not be able to speak about replacement of steel or steel bar or replacement of wire mesh at all in any of the civil engineering aspects. So why this slide is a very important slide for a lot of us. So which are the places where we can use this fiber? All your slab on grades, whether it is parking area, industrial floors, pavements, overlays, is especially the overlays. I see a lot of places. I've got some good examples to you. A lot of multi-level car parkings or a lot of multi-level. This one we have RCC slab, and again we have a 75 mm of concrete. So for 75 mm of screed concrete, when you do structural screed concrete, we again add reinforcement. Okay, so a lot of places you can eliminate the steel usage at all. So you can avoid cracking, you can eliminate steel, this one. So this is advantages. So I spoke to one of the top consultants in Bangalore. They told me the non-structural element concrete in a condominium project or any project is almost to the tune of around 27 to 28% of the project. Okay, so even if you reduce 27 to 28% of the project without using steel, that's a big saving to the country, and also probably you will be making the concrete much more durable. So that's what I can vouch from this slide, is see whether we can differentiate between non-structural concrete and structural concrete. So precast, I said, short retaining walls. So typically where we do not advise that you cannot, a lot of people come and ask, can I put it in the beams? Yeah, you can put it in the beams, but you cannot replace the steel. Okay, let's be very clear about it. You cannot do anything to do with, there is a lot of global R&D going on with a lot of different types of fibers, length, diameter and other things to replace the main thing, but it's not happened. Yeah, there are a few buildings I heard from my colleagues in US they've done, but it is not viable when it comes to the cost. So the slab, you cannot replace steel, beams you cannot replace, columns you cannot replace. So anything to do with structural behavior of the building or any part of it cannot be replaced by any type of fibers. Yes, the bottom portion of the photo gives you an idea about you can reduce the reinforcement by using the macrofibers to see that the concrete goes, when you are doing a self-compacting concrete or a high flow concrete, it goes in between the reinforcement when you can reduce the steel which is used for drying shrinkage, plastic shrinkage, and temperature shrinkage part of it. So that portion of the steel can be reduced, which is in the reinforcement, and leave the gap open up so that the aggregates and other things can make the structure much more durable by getting into the system. So this is called as hybrid systems. So we are not moved into that, but in US, this is a very common phenomena when it comes to macrofibers being used. Here again, I just want to make a pictorial one. Please do not try to use in any of the things saying that I can replace steel with this fibers, macrofibers. So these elements cannot be done at all. So you need to have a we do have a global design team, but as I said, we also have got a designer, Mr. Srinivasan, in our Chennai office. So any design has to be done with these people's support. We have them. So why, as I said, we do not speak about adding a packet of fiber. We are all going and we are abiding by the ACI 544.4R guide as a Bible today, which is come out after 30 years. Is what is, if anybody wants this, please talk to Mr. Kaushika. We will try to provide you. Otherwise, go to the ACI website and pick it up. It can give you all technical information and guidance to where you can use fibers for all type of concrete you would like to use. So as we said, we manufacture the fibers in the US. So we have got a big plant. And what is this macrofibers? As I said, in a kg of fiber, you will have 59,000 strands of fibers are going to be in 1 kg of fiber. So that is one thing. Second thing is you need to have a fire rating in some of the elements. You need to have fire rating. And it should be 51 mm in length to be called anywhere between 42 to 51, 52 can be called as macrofibers. So this is what is very important to us. Then what is it all about when it comes to properties? Whether it is dosage, it can vary between 1.8 to 12 kg by design. So again and again, I want to reiterate, nothing what we're talking is without design. We do not recommend any dosages unless that you're adding for a simple plastic shrinkage character. So load, we'll always take the information from you and provide you that this one. So when it is aspect ratio, tensile strength, modulus of elasticity, all of these things are available to you. So this should have this type of properties if you really have to pass the STM standards. So this is a lab. Without this equipment, you cannot get into fiber FRC at all. So this is an Instron machine which does the testing on beams, whether it is C1559, all of this flexural strength, tensile, testing of filaments is very important in this. So this is it is very important to have this equipment. Otherwise, it is otherwise we are just adding fibers like any other fiber, like the microfibers at 900 grams per kg. So these are the testings you need to do. The STM C1609, 1399, then especially rheology properties also are done with 14651. So these are the tests you will have to go through for each and every design when we do any mega projects, whether it is for a slab on grade, whether it is for steel deck, all of this. So I'll just take you through the slab on grade, where we can replace the steel entirely by doing the right design, depending upon the file, K value, and all other part of it. This is a major thing in India today. If you're able to do slab on grade and replace the entire steel for this, it's a big savings. And I'll show you some case studies where there was a massive savings to the customer worth few crores, not only by rupees, also by the time. So what we are doing is conventionally with proper designing, we are moving from having this moving towards this jointless floor or extended joint spacing from a conventional 3x3 or 2x2 is what our standards or whatever we are practicing today. We move that joints to the major thing. We almost go up to around 15 meters by 15 meters. One of our very close associates work with us are moved with fibers and connex put together, which is a shrinkage compensating admixture put together, can move towards at around 12 to 12 meters of they've already touched per panel, which is a big achievement from 2 meters by 2 meters to 12 to 13 meters by 13 meters. It is a big leap what they have taken, and I think that is getting monitored. It's already been few years now. It is under a lot of monitoring in one of the projects in the north of India. So what we talk about on this extended joint spaces, we need to have high flexural strength, fiber reinforcement. See, there is no compromising on curing and other things. So a lot of people say that we add fibers. Do we really have to cure? So some questions keep coming up like this. I'm adding shrinkage reducing agent, shrinkage compensating agent. Should I want to do curing to the concrete? See, some basics cannot be reduced. Please understand, these are really basics where some of the products also need water for a better performance. So what are the advantages? What you see when we are moving from reinforcement concrete to fiber reinforced concrete without steel? You're talking about reducing labor, cost, speed, safety. A lot of people's legs get torn apart. Then you're improving the process because you imagine you're doing a 50,000 square meter job. Imagine tying of reinforcement, getting the reinforcement and replacing it itself is a big process. So you're eliminating in one shot. So once your consolidation is over of soil and you're done your LDP sheet, and from there you simply start with high flow concrete or self-compacting concrete, whatever the best possible thing you can do. We'll be able to do it with reinforcement with fiber macrofibers, and you finish the concrete. So there's a lot of savings. See, left side, you see the way it has been traditionally been used, people trying to lift the reinforcement to for the concrete to move. Basically, what happens? We generally have cover, but the cover is for the sake of telling that there is a cover. By the time you put the cover and the concrete comes inside, a lot of people stamp on it, a lot of trucks moves on it, and it. So the reinforcement is for the sake of reinforcement. It is at the bottom. It is really not there at 50 to 60% of above the concrete. And because of that, you can see the middle thing, which is the cut concrete, is there. The reinforcement is at the bottom and the concrete there. Because of this reinforcement and no fibers available in the concrete, the tendency of the concrete to crack is very, very high. Okay, so this is the reason we say that we need to have fibers into the concrete to reduce or to increase the ability of the concrete to resist cracking. So this is something we should look forward in a futuristic way. Understanding of failure mechanism, a lot of people know about it. When people like Mr. Mohan Ramanathan is also there in the show. So they are the masters in this particular executions. So I've seen their design. So they really understand what is curling, load transfer, joint spacing. So all of this we should understand how to mitigate this by having right mix designs, right subgrade preparation, designing done earlier places. So at least 3 months before the project start, we should have everything in place. So everything boils down to proper planning. You cannot start a excavation and then you tell that, oh, please come with fiber reinforced concrete. That's not the way to do. So load transfers are very important. So you can look at the third photo. It can have a differential settlement, or it can the soil can be loosely compacted. So it has various things. So all these things can be taken care if you're really looking at fiber reinforced concrete. As I said, you can see the fibers spread over across the concrete, whether it is bottom or top or on anyways. So whether it is crack control, whether you're looking at shrinkage control, because it's got a 3D reinforcement and it is feb relating. So you have this reduced on this particular part. Even in the edges, if you see that there is a crack coming up on the construction joint or expansion joint, with fiber reinforced concrete, at least it holds it for back for a longer time because of the post crack resistance what fiber concrete brings into the structure. So as I said, none of these things are done by adding a packet of fibers. These are all done with a lot of calculations. And as I said, from our side, Mr. Srinivasan is available. If anybody wants some support, please connect with Mr. Kaushik for this, and probably we'll see how we can work with QCrete and come back to you on that. Okay, so whether it is, you can look at the design aspects, whether it is which slab thickness you want to choose with a subgrade, with a K value, and flexural strength requirement. So this is all taken into the consideration while designing of fibers, dosage per cubic meter, and then the report will be given to people whoever is interested, whether it's a developer of the warehouse, wherever the industry, or to the RMC ready mix concrete people, or whoever it is. So as I said, it all goes with the calculation. So we are talking about how do we convert steel reinforcement calculation into the fiber reinforcement calculation. So whether it is a single mat calculation, it can be done. Whether it is a double mat calculations to a fiber reinforcement, it can be done. So this is what we apply from a conventional steel reinforced designs to the fiber reinforcement design. So if you can give the information about this today, we can definitely convert it into fiber, and it'll match all the properties of steel, or sometimes it is better than that. Most of the time it is better than that. So that's the reason we are talking about high performance fiber reinforced concrete. So this is a typical example. We have picked it up. When it is people can read whether it is tensile shrinkage and the reinforcement ratios, what is taken at 0.05, 1% and 0.1% and 0.15%. So you can look at the values here. So the required tensile strength residual with the steel reinforcement and the fiber reinforcement, you can see most of the places it is surpassed the conventional steel reinforcement to the calculations. So it is definitely much better when it comes to the calculations. So we should look at designing in this particular aspect. As I said, this is a theoretical, a designed output, what you people will get it. I've just given a typical, this one, my colleague Srinivas helped me in this, putting these things together. How we can do design 1, design 2, design 3 in a different way for the same mixed design and the same subgrade modulus of elasticity, this one modulus, and this then different slab thicknesses, how the load value of different loads and the dosage of fiber differs by this table. So because of so many designs we have done over the past 4-5 years, so this we thought we'll put it up together for everybody to understand that for the same slab thicknesses, different slab thicknesses, we can reduce it, the thicknesses, when the reinforcement of the fiber will go up. But if you want that to happen, we can definitely do it. It is possible. We all should look at the cost engineering also into the picture. Okay, as I said, all bending, whether it's crack control, bending moment, flexural, all these designs will be provided to you people. You can take it up. So, and that is a short this one, and I will just take you through a small project what we did, just to see that whatever I've spoken is also executed in a particular job. So this is one of the jobs in very close to Coimbatore. People know it as Erode. This particular company does the blade for a turbine. This one they do the high-speed shaft generators. So this is what they do in this particular factory. So we were involved as a process. You can people have done the load testing. Sub-base CBR values were taken. Dead loads and live loads were calculated. LDP sheets were put in place. So we had done all the designing were done accordingly. So this was the output of it. Whether it is rack pinion, this one was taken. The rack loading was taken into the clink. Line loading was taken into the picture. Okay, so all these things was provided to the client. What I mean, I'm just showing you the process, what we go through while designing without steel. So this is an execution. So you can look at this. I think a lot of people have mastered it. I'm sure, but still long way to go for to take it to the next level of thing. But you can look at it with a conventional steel reinforcement. Probably you may do tying and everything put together 200 square meter, but this particular job, the person was able to do almost around 1,000 square meters per day. So because of they were able to achieve the timeline in this, and the client was really happy because of the speed. What I think it was, the entire job was done in around 35 to 45 days. The entire job of around 35,000 square meters. So you can look at the finish. You don't even see that there is a difference in the finish, and when you do it rightly. So this was the finish what we achieved. So you can really be confident about the finishes if you do the right, use the right equipment at the right time. So this was the job, how it looks like. And not only we did the internal part of it, we also designed the road around that particular factory, but the dosages are different. that just gives you a glimpse of saying that we don't have to do only the internal area of the slab, slab on ground calculations and do the execution. We also can do the thing where we take the load of the axle load of the trucks and other things which comes to the maximum, and then we put into the calculations and to a software calculation, and then we execute it. So you can understand, you can look at the carbon footprint calculator. We have worked with, our organization in US has worked with Akron University, and you can see the carbon dioxide equivalent in footprint, carbon footprint. It's a massive reduction in this part when it comes to manufacturing to the execution with the reinforcement and without the reinforcement. And another job, which is a lot of jobs, I'm just sharing you some examples so that today we are talking. This job we did was in IKEA, Bangalore. This was a slab on. This was a screed of 75 mm, and it varied between anywhere from 35 mm to around 75 mm to 95 mm. And this was done on a hollow core slab and RCC suspended slabs. And this is where I said these applications are massive in our country. If you're able to reduce steel even in this area as a country, I think everybody will benefit by doing this. So again, we approached with design and build, and it was done with Shapurji Palanji, and FMG was the other people who had worked along with us to execute this particular job. So this is how the project looks like now. It is fully operational. I think it's become a gala event now. People go there for not only shopping, spend a lot of time in outskirts of Bangalore. You can look at the finish, what is come, because ultimately after doing this densification and polish, you can look at the way the concrete looks like now. So a lot of people will have doubts about adding of fibers. The most important thing what we would want to practice is to add the fibers to the dry aggregates as much as possible. I would say we should not compromise on this, because the fibers, a lot of fibers are fibrillated or fibrillating. There are two different words in this. So it is better that once it is gone into the friction between two 10 mm, 20 mm and sand, the fibrillation happens, opens up, and it has a better anchoring into the concrete when it opens up. So it is better that we add these fibers into the dry state. Otherwise, if you add it in when the truck comes into the project site, and then suddenly you add 12 kgs or 15 kgs as per the dosage, even with the microfibers, even if you're adding 900, example 1 kg into 6 kg, 6 cubic meter. The 6 cubic meters, if you do not do the rotation for 10 minutes, and if you do not take the slump to 175 to 200 and do not add fibers at that time, because once the fiber is added, the slump drops to around 110. But if your slump is 110 at the site and you add fibers, it will come down to 25. And then what people do is add water, and then you still have a problem with cracks. So this is something we would look at. The best practices which should always be followed. And we always say to use it in a dry state. If you cannot, please see that the slump is at 175 to 200. Then add your fibers and see that it is around 125 to 150, depending upon what type of concrete you're pouring, should be done. Otherwise, it'll fall down to 25 to 30 mm, which then you start looking at a balling of concrete will happen, and people will start blaming that, yes, I've used fibers, but I had a big issue out of it. Okay, so please understand that execution is also more important after designing is done. Designing, and there's also one of the most important aspects of FRC. You should handle it like any other normal concrete. You should use the ride-on or the regular trowels at the right time. Otherwise, if you are a little bit late, then you may have a few of the fibers popping up. But the good part of polypropylene and polyethylene fibers, or the blend of it, is that even if it pops up, probably you can burn it off. So you don't have any issues, which can be a very big challenge when it comes to steel. Not only during application, over a period of time, 5 years, you have an industry which is more abrasive, and the top layer comes off for whatever reason. then you start finding fibers popping up. Yes, it may happen with these fibers also, but it is not a big deal. It can be burnt, and you can put a fiber reinforced mortar or a proper concreting done properly, patch repair. You will come through it. So as I said, the stepwise ride on or the regular traveling is very, very important to get the best finish out of it. Otherwise, people will say, yes, I had used fibers, but it gave me a nightmare of it, because they would have handled fiber reinforcement concrete as a conventional concrete. Please understand that this is a special concretes. They are not conventional concrete at all. So it has to be planned. It has to be added the way we spoke about. It should be added with the right slump, no addition of water, and the execution of traveling guys coming at the right time and doing it is very, very key for success of any particular fiber reinforced concrete. So you can get as good as this concrete. So why should you compromise if you do a little bit of good planning? So from that slab on grade, I'll just take you through another opportunity where you can replace steel is on the composite deck construction. So which is catching up in India in a very big way. And we need to understand why people are talking about steel composites. Is basically it's very, very fast. It is expensive by what I know when we speak to companies like L&T or other big developers like people. So they always say that the cost is almost, or some structural consultant when we speak, they say it's anywhere between around 25 to 30% is the cost is higher as compared to the RCC structures. But still people go for it because of completion of time. So you earn money, or you earn rent, or whatever is the big IT parks coming in, earn rents much faster as compared to the RCC part. It is better earthquake resistant, flexibility, more carpet area because everything is slender, thin. Dead weights are very, very less. So the use of skilled manpower is also reduced, because otherwise it takes huge skilled manpower coming into the place. Where in India, where there are freebies are too much from each government, you will not be able to get freebie the right skilled labor doing the right execution of the job. So again, we are not talking about anything outside the code, whether we spoke about slab on grade, whether we are talking about deck, we are talking about clearly in STM method, SDI, that is Steel Deck Institute, this one where it is clearly mentioned, you can use steel mesh, you can use steel fibers, you can use macro fibers at a particular dosage is already defined. So there is a definition very clearly, this is very close to 1:5, that every kg of polypropylene fibers, macro fibers added, you need to add almost 4.5 to 5 times of steel fibers. So you need to add so much of material into the concrete. So again, what you are talking about is basically we have put the reinforcement basically on the deck is replaced with macro synthetic fibers. Even in the negative bending moment, either we can increase the dosage of macro fibers, or we can look at a 4 feet reinforcement going across the beam, which can take care of the negative bending moment. So either one way you can think about it, and there are job references or jobs executed with and without of this. So I think you can contact Mr. Kaushika. He would get back to you people to take care of these particular design aspects also. So what are we talking about? The main purpose of adding the reinforcement on the top of the deck is basically for 3 reasons: plastic shrinkage to take care, temperature control, and drying shrinkage. And there are some of the places the people design a little bit on a cantilever side. When the deck goes outside by around a few mm or half a meter or 1 meter, there is a cantilever movement coming in. There you will not be able to use fibers only. You will have to go with a blend of your regular reinforcement and this one together. But in this, the most important thing you are looking at is that this particular fiber has to be qualified for the UL tested with 2 hours fire rating, because any composite deck building has to have 2 hour rated for the entire building. So obviously fiber is one part of it which you have to take care of it. So you look at the advantages here when I'm talking about not adding the speed to the construction. construction increasing the speed. So look at from there, we are adding from the fiber perspective, we are looking at no bending, no cutting, lifting. So the energy is saved to a larger extent of reinforcement. Process improvement, the tying of reinforcement itself is eliminated. So PMC people or quality control people in going in to go and check whether reinforcement is tied properly or not, itself is eliminated. So once deck is erected, you simply come with self-compacting concrete with fiber reinforced self-compacting concrete is good enough to finish your deck with all this puddler part. Only for the fire rating, the few designers do with 8 mm or a 10 mm rod into the slot of a TR60 deck. That is required for fire rating, so please keep in mind. So monitoring is eliminated, waste and theft, around 78% of the reinforcement is eliminated. Time speed is what we are looking at. Safety is taken care to a large extent. A lot of people have told us or shared with us, saying that people tear their foot when it goes between the reinforcement, and again that day, labor day is wasted, or in that particular this one. So if imagine that you are talking about G plus 30, G plus 25, even a 1.5 day or 1.75 days saving per slab for calculation. If I take 2 days, you're talking about almost 45 to 50 days or 60 days you save only by eliminating the steel into this particular process. So it's a big, anyhow, the steel construction itself is fast. On top of it, with these fibers, macro fibers, you are even increasing the speed of construction by almost 1.5 to 1.75 days per slab. So you need to do, a lot of people are still thinking, okay, how does it really replace steel? So the people have executed jobs, projects have been executed with testing done only with reinforcement. So as per the IS 875, the monitoring, the gauge was fixed to see the bending moment or the recovery of the part at a different slots. And as per the IS 875, the recovery should be more than 75% in the location what was done. And then it was implemented to a bigger project for the load of almost 50 tons was loaded into this particular slab for testing before implementing in one of the particular projects. Again, as I said, addition, self-compacting concrete, flow, there is no compromise on this. No curing cannot be compromised. So please do not, I mean, a lot of people ask why when I'm adding fibers, should I really do curing to avoid shrinkage? So please do not compromise on that. So we are here also see one of the engineers are adding the fibers into the dry mix into the bin directly because they did not have a dispenser, fiber dispenser. So these are the processes, these are the beams. People wanted to understand the way fibers are calculated per cubic meter. It was weighed, it was cleaned, washed, weighed, and seen that it is falling within 10%. This was M30 SCC mix, FRC. So whatever I spoke, you can look at the fibers which is there from literally bottom of the concrete to the edge of the concrete, from the top to bottom. So the spread of the concrete properly added can give you a great high performance fiber reinforced self-compacting concrete. So just want to show you a small video how the testing and the laboratory has to be there. So just to get the glimpse of this. This was just a thing about how the testings and other things have been done, and this is one of the big towers in New York, where it was done by Thornton and Thomas Setti on a composite deck where we replaced the entire reinforcement. Placing and finishing, I think we already spoke about it already on this one. It's the same method. But other than this two data, I just wanted to share the different applications. What opens up for us, at least in these jobs, is that we can really work on eliminating the reinforcement. Is on precast, this one, precast septic tanks, water tanks. The non-structural elements can always be done with this easily. So this is what is there. This is steel fibers and macrofibers have been used in precast elements here, replacing the entire steel. But there's a lot of data going on. This railway panels, spun pipes, drain manholes, all these things can be done with macrofibers. So underground, whether you're talking about shotcreting, whether you're talking about lining concrete, you can look at the welded mesh replaced, or if you're going for a single shell lining directly, that also can be done with this. Then other new codes are coming inside. You have to understand is on the passive protection, fire protection against passive protection against fire. These microfibers have been used in any of the transport tunnels, just to see that if there is a fire and there is a smoke or this one. So this particular fibers burn at around 165-degree temperature, and as a micropores created in the concrete, which allows the particular smokes to go out, the bad smoke, so that the people do not inhale it and die. So that is one of the reasons you see hot gases and other things get eliminated, escapes out from there. So this is what is happening in some of the specifications which are coming out of late. Payments, we spoke about it. The big jobs have been done like this. This is an interesting data between plain concrete, reinforced concrete, and FRC, especially for a wide water or a liquid tightness project done by one of the studies, where you can see the crack which goes through and through, because it eliminates the fibers intercept the cracks. What happens within the concrete? The waterproofing part of it, or the cracks are reduced. So the water retaining part of it by using fibers are increased by almost around 70 to 80%. So this graph shows clearly between plain concrete, reinforced concrete, and FRC concrete. So this is another thing, applications where we can think about increasing the durability of concrete, getting a better permeability into the structure element itself. Lightweight concrete. A lot of people call us and ask us, or there is general coming up is we have got 2 kg. We have got 2 MPa concrete, lightweight concrete poured on the slab, whether it is a terrace slab for insulation or the sunken slabs or any other slab, but it is very, very brittle, or it starts crumbling, because the 2 MPa is not 2 MPa when it starts, when the concrete moves from a batching plant at 0 minute, 2-3 hours rating, the density either increases because the air bubbles into that particular part starts reducing, escaping, and density increases. And the density strength what you get is probably, if you're designing it for 5 MPa, you may get 2 MPa, but because of 2 MPa you start having crushing effect or a crumbling effect. But with that, if you use macrofibers, it gives you the physical property even at the low strength concrete. It improves the physical properties of the particular concrete with flexural, tensile, or impact to at least a reasonable level as compared to the control concrete. So you can think of another application where you can improve or take the lightweight concrete to the next level, or bricks, concrete blocks, pumped concrete, whatever we're talking about. So walls, you can look at this one for explosion resistance part of it. See, this is a classic example of one of the canals where they reduced double mat reinforcement was pulled down to single mat reinforcement by using macrofibers. So even this type of designings we also do for the slab on grade applications, Wherever you don't want to go for double mat, you can always go for single mat. Imagine a canal of running into few hundred kilometers, and you remove the one reinforcement part of it. Imagine the savings what you have for the entire particular project. It will run into few crores. This is a classic thing where you want designing of polished concrete, or this one we are talking about exposed polished concrete. You cannot afford to have micro cracks or anything coming inside. So this is where your fibers help you to have a concrete without cracks, and you can expose your color concrete of polished concrete directly. So this is what is microfibers. Microfibers, I'll just touch the microfibers. As I said earlier, macrofibers is 51 mm, microfibers is 10 mm, and 10 mm is only used for at 900 grams per cubic meter, only used for taking care of the drying shrinkage of the particular concrete. Please do not use this fiber for any structural replacement at any cost. Okay, so this is what we use. Definitely, this has got a great advantage against plastic shrinkage. So this is something you can use it for. Because generally what happens when you go to the construction site, we generally see this very, very often. Okay, so this is something which you can take care by using microfibers. And typically the most important thing all of us to learn from the civil engineering part of it, the more the water, the drying shrinkage is already given to you on the left side on that. So the more the water, the drying shrinkage is going to be coming up very, very hard on you. So you have to see that it is kept on a nominal level on this particular part to see that you have a durable concrete clearly against each water cement ratio. Also, when you're working on shrinkage versus cracking on this particular part, for every calculation, see, all of this are actually done by structural engineers. So when they're looking at shrinkage design in the reinforcement, it means that if they're designing at 0.08%, you're likely to have 1 inch crack. If they're designing at 0.05, you're likely to have 7.5 mm, okay, for over 100 feet length. So these are some things which we should keep in mind when we are designing of concrete, or when you are planning our concrete, or when you are putting things together for high performance concrete together. So these are typical things which with microfibers we'll be able to eliminate when all of us know why plastic shrinkage happen. The water, when you put the concrete inside into it, it moves into the atmosphere, and the voids are created. And in that particular voids, you have a surface tension coming in when the water is sucked out from the particular concrete, and that creates the weak pore. And then you start seeing the cracks in this particular pattern. So I just want to summarize on this particular part. So what we can do, all of us, is that we can differentiate between structural and non-structural element of the concrete volumes in each particular project, design it as per the KOLLAM practice, take the advantage of speed of construction because it's all about money, you're saving money. Take the advantage of not only taking care of the shrinkage reduction, take the advantage of improving the physical properties of concrete with fiber reinforced concrete, with FRC, and you get the benefit of both speed, you can eliminate corrosion, you can eliminate speed, all these thing advantages are there with you. Then you look at eliminate. I would not say eliminating is not the right word, but at least your work is not stopped because of the skilled labor wanting in today's scenario. You have got increased safety hours in each site because a lot of projects run on safety hours, manpower loss because of safety. So that's very important. Second part of it, all of us know, is eliminate the process of storage of steel, scheduling of bar bending, cutting, lifting, tying, checking the reinforcement, and the energy saving required for all of these particular things, whether it is cutting, bending, lifting, the cranes which are required. All these things can be eliminated as you plan for a particular projects. So most other thing is again wastage. We are talking about somebody cutting it and it's not fitting in, it's thrown. And on top of it, you also got theft, because today's steel is almost around anywhere between 65,000 to 85,000 rupees. It is offering per ton. So it's not cheap. So all these things leads to direct and indirect savings to the particular project other than improving the durability of concrete, integrity of concrete. So I was just telling Doctor earlier, starting the particular program, is that when slag and fly ash have started replacing cement and making it more durable, this thing, I think we should look at seeing whether we can replace steel in the non-structural part of the structure with fibers, and see that we can add value to the particular project, durable thing, and also reduce the dependency of manufacturing steel, which is a very, very big process by itself, by cost or by energy. So this is what I would like to summarize, and I would like to thank each one of you for your time and patient hearing. I hope I've kept my time. And for questions, comments, and feedback, probably I think Mr. Kaushika is there. So I would like to thank each one of you for the time given to us. Thank you, everyone.
Thank you so much, sir. Sir, next we'll move to the question answer session. I'll read out 4 to 5 questions and you can answer them, sir.
Okay.
So the first question is, will it reduce the construction cost and a profitable source of income for farmers? Sorry, sir. How is fire resistance of fiber reinforced concrete? And that was asked by Sumanta Sahu.
Yeah, this is especially required for composite deck, because why it is needed is 2 hours they keep it today. After the World Trade Center fire which caught up in the US, they talk about taking 2 hours for evacuating the entire people in the building. So the minimum of 2 hours is required when we are looking at it. And if you do not have this particular fire rating, you would not be qualifying for that, for using in that particular structure, especially when it comes to composite deck.
Thank you so much, sir. Next, we have a question asked by Mr. Kantarao, and the question is, which type of fibers are used to prepare ultra high performance concrete?
Madam, Anjali, can you just repeat it?
Sure, sir. Which type of fibers are used to prepare ultra high performance concrete?
See, for preparation of ultra performance concrete, it depends upon what properties you're looking at. As I said, you can blend fibers of different sizes, whether you can use micro also, you can use macro also, you can use in between part of it. And some people are using steel fibers also. There is nothing wrong in that particular perspective. So if you can define the properties required by ultra high strength concrete, whether it is by tensile, flexural, all these properties it is designed, probably we'll be able to come out with the is required for each one of it, and we need to do the trials, and it's a trial and we to do for coming with to come out with a proper dosage for ultra high performance. See, there are 2 things: high performance, high strength, high performance is one part, and high performance concrete of FRC is one part. High performance is not always about getting high strength, okay, but all other properties are also very important in concrete to be called as high performance concrete. It cannot be just called as high performance just because it is M50 or M60 or M80 or M100. High performance also can be called for even M30 or M35 also, because the properties of other properties of concrete gets improved because of this. Whether it is durability, there is a testing. Whether it is a permeability reduction, there is a testing for it. So this particular properties are more important to be called as high performance not concrete rather than only grade of concrete.
Thank you, sir. Next, we have a question asked by Mr. Kumar, and the question is, are these steel fibers susceptible to corrosion?
Generally, it should not be. frankly, if it is been quenched properly, everything is done as per the standard, you should not have. But if there is any dilution of adding another material into that part, yes, it can be susceptible. Also, you should be careful about the chemical resistance also when it comes. But when it comes to example, I would say is it is a no-no when it comes to electronic industry, where you have got magnetic thing coming up. There you would have some challenges. It would have attraction towards that part of it. Otherwise, I think it goes through without much problem.
Thank you, sir. The next question is, at which places do we need to use fiber reinforced concrete?
Can I go back to the slide? See, as I said, okay, this was a starting point. Okay. See, these are the places you can easily replace steel with macrofibers. So you can look at slab on grade, parking, industrial area, pavements, overlays, screeds in a tall structures, composite deck I spoke in length, shotcreting in tunnels, slopes, pools, repairs. All these places you can, but everything has to be designed. I'm again and again talking about not adding a packet of fiber. In these locations, you cannot use very clearly because still there is global R&D is going on. The few projects they say they have done, but I have less information on that on this. But on a suspended slab, a structural slab, column beams, cantilevers, you cannot use or replace macrofibers replacing steel. Yes, you can replace steel in places where the congested reinforcement is there. For a steel which is used for added for plastic shrinkage, drying shrinkage, and temperature control, that can be removed and made a space for concrete to come inside with macrofibers, because that will give the properties of steel which would have given it if you would not have replaced it. So these are the two places you can use it, and we should not use it.
Thank you, sir. Next, we have a question asked by Mr. Nana Mulik. And the question is, what is the difference between polypropylene fiber and steel fiber in terms of strength?
The strength I've already mentioned. Yes, steel would always be ahead in the strength part in some of the parameters. Okay, but more importantly is by strength of two different materials, you will not able to come anything. You will have to put it, like as I said, the dosage of steel fiber is anywhere from 12 to 60 kgs. Okay, whereas macrofibers, polypropylene fibers, can vary from 1.8 kg to 12 kgs only. So it is 1:4.5 to 5 depending upon the design. So whatever the parameters of concrete properties you want, you can design it either with steel fibers or polypropylene fibers. Most important is please define the properties of concrete and use one of them. There is no problem in that. And we will submit. Everybody has to submit the report. The most important thing is submission of report for a particular load. Then the rack load, the pinion load, everything has to be calculated and then allowed to be used.
Thank you, sir. Next, we have a question asked by Mr. Umesh Achar, and the question is, how do you differentiate use of steel and polypropylene macrofiber?
As again I said, there are two different materials very clearly. We should choose the materials depending upon its properties and whether it is meeting your requirement of design, whether it is slab on grade, whether it is shotcrete, because both have got their own advantages. Steel has got its own advantages and disadvantages. Even this has got own advantages and disadvantages. To make the best use of the advantages rather than talking negative about each other, use what is easily can be handled, designed, and meeting the properties. Otherwise, both of them will meet the properties of flexural. It will meet the properties of tensile. Or it will meet the of temperature control shrinkage cracks. Everything will done, but the dosage will vary. I'm telling you again, it is 1:4.5 to 5 times is the usage. So the handling of steel fibers, example, in a batching plant, okay, you have to add, if you imagine that your design comes out at around 25 kg per cubic meter. So 25 into 6, almost around 130 to 140 kg per cubic meter. So handling can be a challenge, first part. Second part, safety. People can tear open their hands if they've not used their this one. Third thing is, while pumping the concrete into to a larger distance, the erosion of the concrete pipeline will be very, very high as compared to polypropylene fibers. So you will have advantages and disadvantages from both of them. Pick up the right one, which is meeting your meeting the properties of concrete.
Thank you, sir. We have one final question, and it is, what is the effect of residual strength of concrete when macrofibers are used compared to steel fibers? And that was asked by Mr. Anarwan.
Yeah, so there is no, there would not be much increase in strength. So don't go by strength increase. Even if it increases, it probably can increase by around 5 to 7% max. So don't go by using of fibers, whether it is steel or macrofibers, for increasing the. You look at the other properties of replacing of steel. That is more important to you. Strength will be additional thing. You can take it. I would say you can take it as a bonus. It is just a bonus, and we see with our experience it can vary anywhere from 5 to 7% only, because strength is all about other properties, compaction, then your water cement ratio, and other thing plays a bigger role. So other properties are more important when you are talking about fiber reinforced concrete, especially with flexural and tensile and temperature control cracks, and other properties are more important to us.
Thank you so much, sir. We are done with the question answer session. Now I welcome Engineer Liji Anna Matthew for the vote of thanks.
Hello, am I audible?
Yeah.
Yes, ma'am. Ma'am, you may continue, ma'am.
Hello. Hello.
Yes, ma'am, you are audible. Sorry for the inconvenience caused. Dr. Elson John, I welcome you for the vote of thanks.
Thank you, Engineer Anil Anjanappa, for giving this wonderful lecture on fibers. And you have dealt with this subject in a very detailed manner, including going into some minor and major details of design, how to use different kinds of fibers and things like that. We, on behalf of QCrete Ready-Mix Concrete India Private Limited, and also on the Cochin Indian Concrete Institute chapter, we are thankful to you, sir. And we are also thankful to all the audience for coming up on this Friday night and listening to us. Thanks a lot. Thank you.
Thank you, sir. Thank you for giving us an opportunity. Really appreciate it.
Thank you. Thank you. We also thank our MD, Shale Fernandez, sir, for organizing this, and all the office bearers of Indian Concrete Institute Cochin chapter, and also Anjali on behalf of QCrete Ready-Mix for conducting this. Thank you.
Thank you, sir.